This is part three of, there we go. This is part three of the chapter 10 lectures. Um, what my goal is going to be is to get through the section on levers, the different types of levers, and then the rest of the chapter focuses on groups of muscles that, the groups of muscles that carry out a certain action. And you really just have to learn those. Your A and P flicks will help. But anyway, let's go back. Let's get back to levers. Remember that when we talk about levers, we're going to focus on the fulcrum, the load, and the effort. So LEF. So the lever system that has the most power, the power lever, means that it has mechanical advantage. And that means the load is close to the fulcrum and the effort is far from the fulcrum. So how would we write that with our E, L, and F? If the load is close to the fulcrum, and the effort is far from the fulcrum, it's going to be like this. Fulcrum, load, effort. And the lever that's going to have the most mechanical advantage is going to be a second class lever system. A second class lever system, which we'll talk more about. And so the levers with mechanical disadvantage are more for speed. And in this case, the load is far from the fulcrum and the effort is close to the fulcrum. So that's going to be E, F, L. That would have a mechanical disadvantage. So the basic principle is this. If the effort is farther than the load from the fulcrum, then the lever operates at mechanical advantage or power. If the effort is nearer than the load to the fulcrum, then the lever operates at mechanical disadvantage, but it would be faster, be a speed lever. So up here at the top, the mechanical advantage is going to be when the effort is farther than the load from the fulcrum. So that would be E, F, L. Effort is farther than the load from the fulcrum. For some reason that doesn't seem right. No, it's FLE. Sorry. Here's your fulcrum. Here's your effort. And here's your load, and here's your effort. So the effort is farther than the load from the fulcrum. That works. Okay, and then when the effort is nearer than the load to the fulcrum, then that's going to be mechanical disadvantage, and that would be EFL. Effort, fulcrum, load. Okay, so let's look at a lever that we can understand, that we can, mechanical lever, forget about bones and muscles. All right, so this man has a, like a bar, crowbar, that kind of thing. The load is the big rock that he's trying to move. The fulcrum is the point of movement, so that would be like the joint. And the effort is that he is going to push down. So the longer that bar is, the more force can be applied, the more mechanical advantage there would be. So this would be load, fulcrum, effort. So if we go back, we haven't learned one like that yet. But this does give you mechanical advantage whenever the effort is further from the fulcrum than the load is. So you can still have the effort further from the fulcrum, you see the distance from the fulcrum to the effort is this, and the distance from the fulcrum to the load is this. So you can tell that the distance from the fulcrum to the effort is greater than from the fulcrum to the load. And if we go back to our other example, says the load is close to the fulcrum with the effort far from the fulcrum, but that's still, this pattern still works because you still have the distance from the load. The distance from the load and the fulcrum is shorter than the distance from the fulcrum and the effort. Okay, so you've got LFE, load, fulcrum, effort, and you can see the distance from the fulcrum to the effort is great. And that's going to be a power lever that's going to give you mechanical advantage. Now, a speed lever is like a seesaw. So your fulcrum is in the middle, your distance from your fulcrum to your effort is short, and the distance from the fulcrum to the load is long. So this is going to be mechanical disadvantage, but it does give you speed. So this would be LFE. Same pattern, but the distances are what we're looking at. The LFE pattern, when the distance between here and here is short, you have mechanical disadvantage. But when you have the LFE pattern and the distance between here and here is long, you have mechanical advantage or power. Okay, so most of your questions are about the classes of lever system, and that is based on the position of the effort, the fulcrum, and the load. A first class lever system has the fulcrum between the load and the effort. So you've got load, load, fulcrum, effort, like we just looked at. A seesaw is an example of a first-class lever. Scissors are examples of first-class levers. First-class levers can have mechanical advantage if this distance is the longer distance between the fulcrum and the effort. If this distance is long between the fulcrum and the effort, then that's going to give you a first-class lever. I do know an example in the human body of a first-class lever is when you move, like you have, let's say you have your chest, your head resting on your chest, and you lift it up. Lift, head up off of chest. That movement, it's a movement of your neck. Like put your head down until your chin touches your chest, then lift it up. That is like a first class lever. The load is going to be your head, the fulcrum is your neck, and then the effort is going to be, and by the way, this is going to be a first class lever where the it has a mechanical disadvantage, speed but not power. And so what we can see here is that in a first-class lever, you can either have the distance between the fulcrum and the effort can be long, or the distance between the fulcrum and the effort can be with scissors, it's almost equal, right? Okay, so again, another example of a first-class lever is lifting your head up off of your chest. There we go. The fulcrum is at your neck. The effort is this muscle right here, which is a posterior neck muscle. And so it's going to be pulling your head up. So your head itself is the load. So that would be LFE. That would be load, fulcrum, effort. A second class lever would be when the load is between the fulcrum and the effort. The example of a mechanical one is a wheelbarrow, and then standing on your toes would be the human body one. So this is when you have your fulcrum. For a wheelbarrow, the fulcrum is the wheel, is at the wheel. The load is in the barrel, and then your effort is applied here. Okay, so this would be F, L, E, and this has the greatest mechanical advantage. This would be a power lever. It's got the greatest mechanical advantage. And an example would be standing on your toes. So the fulcrum is actually the joint where your digits attach to your metatarsals. Your phalanges or your toes attached to your metatarsals or the bones of your foot. And the load is the weight of your body, really, because I mean, your whole body. The effort is from your gastrocnemius and your soleus muscles. But the primary effort is the gastrocnemius muscle, which you see here in this picture. So this is an example of a power lever, a second class lever, okay? If you think about it, it takes a lot of power to stand on your tiptoes, especially for a long time. Then a third class lever is when you have the fulcrum, the effort, and the load. So tweezers, where you have a fulcrum here, and then I'm trying to think what the load would be. The load is here, and then the effort is usually you put your fingers in the middle of the tweezers. Forceps and most skeletal muscles are third class levers. So that would be LEF. Yeah, it shows that's where it shows LEF. Yeah, I did it right. It just seemed weird. All right, so the load is you're having to squeeze the tweezers closed, so that's the heaviest part would be the open end of the tweezers. The fulcrum is the point like that acts as a joint, and then the effort when you squeeze tweezers or forceps, you're applying the effort in the center. So that's a third class lever, and third class levers have a mechanical disadvantage. They're fast, but they are not powerful. They're not powerful. A very good example of a third class lever is something called a bicep curl, flexing at the elbow. Your elbow joint is the fulcrum. The bicep muscle is the effort, and it attaches right here. And then the load is whatever load that you're lifting. It can even just be your forearm. Okay, so the effort being the muscle, the bicep muscle is here, and that's where the effort is. That would give you the pattern LFE, and that is a third class lever. All right, so in summary, the speed levers have a mechanical disadvantage in power, but they're faster. And a third class lever is a good example. A first class lever can be either one. Some first class levers have a mechanical disadvantage and some have a mechanical advantage. Remember, it has to do with the distance between the fulcrum and the effort. If that distance is long, then you're going to have a mechanical advantage. But if it is short, then you won't. You'll have a mechanical disadvantage. So in mechanical advantage, the most powerful levers are second class levers, but you can also have first class levers where the distance is long between, let's go back to it, sorry, where the distance is long between the fulcrum and the effort,